This is the side of Mount St. Helens blowing out 45 years ago.
Of Mount St. Helens in southwest Washington state, imponderables dust the air like volcanic ash.
The tremors beneath Mount St. Helens have surged in frequency and intensity, prompting the United States Geological Survey to issue a rare red alert. This designation is not given lightly. It signals that seismic activity has reached a threshold suggesting a strong possibility of significant volcanic unrest. The mountain, etched into American memory for its catastrophic 1980 eruption, is once again drawing the attention of scientists, emergency officials, and communities across the Pacific Northwest. What makes this alert particularly striking is not just the number of tremors, but the clustering of seismic swarms in patterns that often precede magmatic movement deep within the Earth's crust, underscoring the immense geological forces currently stirring beneath the surface. Before we start, smash the like and subscribe buttons for more updates. Mount St. Helens is no stranger to upheaval. As one of the most active volcanoes in the Cascade Range, it has long been monitored with an array of seismic instruments, GPS stations, and satellite imaging. For decades, the mountain has exhibited a cycle of quiet periods punctuated by episodes of heightened unrest. However, the recent spike in tremors is unusual in its persistence and density. Hundreds of microquakes have been recorded over a short span, each a whisper of shifting rock and rising magma. These tremors, though small on their own, collectively paint a picture of a restless volcano whose internal systems are under strain. The red alert signals that scientists now believe the subterranean movements have crossed a threshold that could escalate rapidly if conditions align. The implications of this development are far-reaching. A red alert does not mean an eruption is inevitable, but it does elevate the level of preparedness for nearby communities, industries, and infrastructure. Emergency management agencies across Washington and Oregon are undoubtedly reviewing evacuation plans, communication networks, and logistical contingencies. The memory of the 1980 eruption, which flattened forests, destroyed homes, and claimed lives, still looms large in the regional consciousness. While technology and monitoring capabilities have advanced significantly since then, the unpredictable nature of volcanic systems means that uncertainty will always remain. This uncertainty is what drives both scientific investigation and public concern. The science behind the tremors reveals the intricate processes at work beneath Mount St. Helens. Volcanic tremors are not the same as tectonic earthquakes, which occur when fault lines slip. Instead, they are often caused by the movement of magma, gas, and superheated fluids through cracks and conduits deep underground. The recent spike in seismicity suggests that magma may be forcing its way upward, pressurizing the mountain's interior. This activity creates small fractures in surrounding rock, which release energy as tremors. The clustering of these events into swarms indicates that the pressure is not isolated, but systemic, potentially affecting a wide network of pathways within the volcanic edifice. It is this systemic pressure that raises the stakes and justifies the issuance of a red alert. For geologists and volcanologists, this moment is both a challenge and an opportunity. Mount St. Helens offers one of the most closely studied volcanic systems in the world, a natural laboratory where theory meets reality. The instruments deployed around the volcano are capturing vast amounts of data in real time, from seismic waveforms to ground deformation and gas emissions. These data streams are invaluable for refining models of volcanic behavior. Yet even with the most sophisticated tools, prediction remains an art balanced on the edge of science. The red alert underscores the limitations of human knowledge while highlighting the importance of preparedness. Every tremor, every change in gas output, every subtle bulge in the mountain's surface is a clue to a larger mystery that scientists are racing to solve. The human dimension of this alert cannot be overstated. Communities surrounding Mount St. Helens live with the dual reality of natural beauty and natural hazard. The forests, rivers, and recreational lands that draw visitors from across the nation are also within the potential reach of volcanic fallout. Local economies that depend on tourism, logging, and agriculture must now weigh the risks posed by possible volcanic activity. Residents who remember the devastation of 1980 may feel a resurgence of anxiety, while younger generations confront the reality that the mountain's quiet years were never a guarantee of permanent calm. Preparedness campaigns, public briefings, and educational outreach are essential tools for ensuring that fear does not spiral into panic. Clear communication from the USGS and local authorities will be critical in navigating this tense period. The environmental implications of a potential escalation at Mount St. Helens extend beyond human concerns. Volcanic activity reshapes ecosystems in profound ways. The 1980 eruption, despite its destruction, eventually gave rise to a remarkable ecological recovery, with new plant and animal communities colonizing the scarred landscape. If the current tremors are precursors to another eruption, the ecological fabric of the region could again face upheaval. Ash fallout can smother vegetation, disrupt waterways, and alter soil chemistry. Wildlife may be displaced or perish in the immediate blast zone. Yet in the long arc of time, such disturbances are also drivers of renewal and adaptation, a reminder of the Earth's cycles of destruction and rebirth. For scientists studying ecological resilience, the unfolding situation may provide fresh insights into how life responds to catastrophic change. From a broader geological perspective, the unrest beneath Mount St. Helens fits into the grand narrative of the Cascade Volcanic Arc. Stretching from northern California into British Columbia, this chain of volcanoes owes its existence to the slow and relentless subduction of the Juan de Fuca plate beneath the North American plate. Mount St. Helens is one node in this dynamic system, a pressure valve through which the Earth's interior expresses its energy. Tremors beneath one volcano may hold implications for others in the chain, as the entire system is interconnected through tectonic and magmatic processes. While each volcano has its own personality and behavior, the activity at Mount St. Helens may encourage scientists to revisit monitoring strategies across the region, ensuring that no potential threat goes unnoticed. The cultural significance of Mount St. Helens also colors the response to the Red Alert. For indigenous peoples of the Pacific Northwest, the mountain has long held spiritual meaning, woven into stories and traditions that recognize its power. The current tremors and scientific alarms are layered atop centuries of human experience with the volcano, reminding us that modern technology is but one way of knowing. The reverence with which the mountain is regarded underscores the need for respect as well as scientific scrutiny. In times of heightened activity, cultural voices provide depth to the conversation, grounding the event in a context that transcends data points and hazard models. Technological advancements since 1980 have transformed how the USGS and partner organizations can respond to volcanic unrest. Satellites now orbit overhead, tracking minute shifts in the mountain's surface. Drone technology allows for aerial surveys of areas too dangerous for human entry. High-performance computing enables the simulation of eruption scenarios with remarkable detail. Social media platforms provide channels for rapid dissemination of information, ensuring that alerts reach wide audiences within moments. The issuance of a red alert in this era is thus not just a scientific statement, but a coordinated communication effort, leveraging tools that did not exist when Mount St. Helens last made global headlines. The effectiveness of this system will be tested in the days and weeks ahead as tremors continue to rattle the region. On an economic scale, the tremors and the red alert ripple outward. Infrastructure such as highways, bridges, and power lines in the vicinity of Mount St. Helens are all potential points of vulnerability should volcanic activity escalate. The Columbia River, a vital artery for commerce, could be impacted by ashfall or lahars that alter its flow. Air traffic, too, is a concern, as volcanic ash poses severe risks to jet engines. Airlines and airports in the Pacific Northwest are likely reviewing contingency plans, mindful of how eruptions in places like Iceland have disrupted global aviation in recent years. The red alert is therefore not merely a regional issue, but one with national and even international implications, particularly in a world where supply chains and travel networks are tightly interwoven. In the scientific community, the tremor spike is sparking intense collaboration. Teams across universities, research institutions, and government agencies are pooling expertise to interpret the data. Each discipline brings its own lens. Seismologists parse waveforms, geochemists analyze gas emissions, geodesists track ground deformation, and modelers integrate these strands into predictive frameworks. The red alert provides a rallying point for this interdisciplinary effort, accelerating the pace of research and communication. Conferences, workshops, and emergency meetings will be dominated by discussions of Mount St. Helens, reinforcing its role as a focal point of global volcanology. For students and early career scientists, the current unrest is a formative moment, an opportunity to witness science unfolding in real time under the pressure of public need. Psychologically, the spike in tremors and the subsequent alert challenge the human desire for stability. Living in the shadow of an active volcano is a reminder that control is often an illusion. Preparedness measures can mitigate risks, but they cannot erase the underlying reality of geological volatility. For many residents, the experience of feeling the earth tremble, even subtly, awakens primal fears. The role of community leaders and officials becomes one of guiding collective resilience, helping people to face uncertainty with courage rather than despair. Schools, workplaces, and families will all be having conversations about what the red alert means, weaving preparedness into daily life until the volcano's behavior clarifies. Globally, the events at Mount St. Helens resonate beyond the Cascade Range. Volcanic eruptions, especially in well-monitored regions, serve as reminders of planetary dynamics that affect all of humanity. Lessons learned here may be applied to monitoring systems in other volcanic hotspots, from the Philippines to Italy to South America. The international community of volcanologists is watching closely, sharing data and insights in the spirit of scientific solidarity. Mount St. Helens, once again at the center of global attention, underscores the interconnectedness of human societies in the face of natural phenomena. The tremors beneath its slopes are not just local events, but part of a planetary narrative of fire, pressure, and change. The issuance of a red alert also prompts reflection on human adaptation to natural hazards. Cities and towns in the Pacific Northwest have grown and modernized in the decades since the last major eruption. Populations have increased, and development has expanded into areas that may be vulnerable. The challenge now lies in balancing growth with safety, ensuring that lessons from the past are not forgotten. Building codes, land use policies, and emergency infrastructure are all tested in moments like this. The red alert serves as a stress test for systems designed to protect lives and property, revealing both strengths and vulnerabilities. It is a reminder that coexisting with a volcano requires not only vigilance, but humility. As tremors continue to rattle beneath Mount St. Helens, the world watches with anticipation and unease. Each shake of the earth is a message from deep within, a signal that the story of this iconic volcano is still unfolding. The red alert transforms these tremors from background noise into urgent communications, demanding attention and respect. Whether this episode culminates in an eruption or subsides into quiet once more, it will leave an imprint on the scientific record, the regional psyche, and the global understanding of volcanic behavior. The mountain has spoken through tremors, and humanity must listen, prepare, and respond with the knowledge that in the grand dialogue between Earth and life, silence is never permanent. The surge of seismic unrest beneath Mount St. Helens has ignited a storm of curiosity and unease, not just in the Pacific Northwest, but across the broader global community of people who watch volcanoes as indicators of Earth's inner workings. The red alert from the USGS is not simply a technical announcement. It is a symbol of the mountain reclaiming attention, demanding that human society once again focus on its subterranean drama. To expand on what has already been established, it is important to explore the broader geological significance, the deeper cultural resonance, and the layered implications this escalation has for science, safety, and human imagination. Mount St. Helens, though often associated with its catastrophic 1980 eruption, is part of a lineage of eruptions stretching back thousands of years. Archaeological and geological records show that the mountain has erupted repeatedly, shaping the surrounding landscape with layers of ash, pumice, and lava flows. Each eruption was a punctuation mark in the long story of the Cascades, and each left behind traces that scientists now use to reconstruct the volcano's patterns. The current tremor spike, therefore, is not an isolated anomaly, but part of a continuum of activity that reflects the mountain's place in the living geology of North America. The red alert signifies that this ancient rhythm has accelerated into a tempo that cannot be ignored. To fully appreciate the significance of this event, one must consider the mechanics of volcanic systems in the Cascades. Unlike basaltic shield volcanoes like those in Hawaii, which produce relatively gentle lava flows, stratovolcanoes such as Mount St. Helens are known for their explosive potential. This is due to the viscous, silica-rich magma that tends to trap gases until pressure builds to catastrophic levels. The tremors currently reverberating beneath the mountain may indicate that such pressure is once again accumulating. These signals are a reminder of how geology dictates behavior. Composition shapes the style of eruption, and in this case, the potential leans toward violence. The red alert is thus a recognition of both the physics of magma and the history of this particular volcano. Beyond the mechanics, there is the landscape itself, which bears scars of past upheavals. Vast swaths of forest around the volcano were obliterated in 1980, replaced over decades with younger growth that now blankets the slopes. Rivers were rerouted, lakes formed in craters, and entire valleys were filled with debris. When tremors shake beneath Mount St. Helens today, they reverberate through a terrain that is itself a monument to resilience. The forests that regrew, the wildlife that returned, and the ecosystems that adapted all testify to the cycles of destruction and renewal that define volcanic environments. A new period of unrest could once again reshape this landscape, reminding observers of the impermanence of what seems solid and enduring. Another dimension of the red alert is the human tendency to mythologize natural phenomena. For centuries, indigenous peoples of the Pacific Northwest carried stories about the mountain, often portraying it as a powerful being with moods and tempers. These stories captured the essence of what modern science also recognizes, that the mountain is alive in a way, not in a biological sense, but as a dynamic system. Today's red alert continues this narrative thread. Even as scientists explain tremors through tectonics and magma dynamics, the mountain's rumblings resonate with symbolic meaning. To many, it is not just a geological event, but a reminder of humanity's smallness in the face of Earth's vast processes. The cultural imagination surrounding Mount St. Helens extends into art, literature, and collective memory. The mountain's eruption in 1980 was documented in photographs, films, and eyewitness accounts that entered the canon of modern natural disasters. Paintings, songs, and even children's books have since celebrated the recovery of the area. With the new surge in tremors, artists and storytellers may again find inspiration in the drama unfolding beneath the peak. The red alert becomes not just a technical level of hazard, but a theme that can stir creativity, reflection, and dialogue about humanity's relationship with nature. Such cultural expressions ensure that the story of Mount St. Helens is not confined to scientific reports, but lives on in the imagination of society. From a strategic perspective, the tremors highlight the importance of disaster readiness in regions prone to volcanic activity. Communities in the Pacific Northwest must consider not only the immediate dangers of eruption, but the secondary effects that ripple outward. Ashfall, for instance, can travel hundreds of miles, clogging machinery, contaminating water supplies, and posing respiratory hazards. Lahars, or volcanic mudflows, can race down river valleys with little warning, endangering communities far from the eruption site. The red alert thus serves as a rehearsal in preparedness, compelling authorities to test systems, strengthen networks, and remind the public of evacuation routes and safety protocols. Preparedness is not simply a bureaucratic exercise, but a lifeline in moments when seconds count. The tremor spike also underscores the interplay between local and national resilience. While Mount St. Helens primarily threatens communities in Washington and Oregon, its potential effects touch national interests. Timber industries, agriculture, and transportation networks are deeply integrated into the national economy. Disruption in the Pacific Northwest can ripple into supply chains across the country. The federal government, therefore, has a vested interest in supporting monitoring, research, and emergency response in the region. The issuance of a red alert is not just a regional event, but a signal to national agencies that readiness must be scaled up. In this sense, the mountain becomes a test case for national disaster resilience, measuring the capacity to coordinate across local, state, and federal levels. The international context adds another layer. Volcanic unrest at Mount St. Helens is not occurring in isolation. It is part of a global pattern of volcanic activity. At any given time, dozens of volcanoes are erupting or showing signs of unrest worldwide. The data gathered in Washington can feed into global models, enhancing prediction and risk assessment elsewhere. For example, lessons learned about the early warning signs of eruption here might be applied in densely populated volcanic regions such as Indonesia or Central America. Conversely, international experience informs how scientists interpret the signals at Mount St. Helens. The red alert is therefore not just an American matter, but part of a global conversation about how humanity coexists with volcanoes. In the realm of technology, the monitoring of Mount St. Helens represents the cutting edge of geoscience. Networks of seismometers transmit data in real time. GPS stations measure subtle ground movements, and satellites scan for thermal anomalies or shifts in elevation. These tools, combined with machine learning algorithms, allow scientists to process vast amounts of data quickly. The tremor spike currently being observed provides an opportunity to test and refine these tools under real-world conditions. A red alert is both a scientific challenge and a technological proving ground, pushing the boundaries of what can be known and predicted. Advances made here could set new benchmarks for volcanic monitoring worldwide. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on USGS Red Alert? Do you expect eruption or calming? We want to hear from you. Thank you for watching and see you next time.